Hey everyone, in this video we're going to be taking a look at glide reflections. A glide reflection is a composition of two transformations. It's a combination of a translation followed by a reflection. So what we're going to do is we're going to take an object, we're going to translate it somewhere, and then we're going to flip it over a line. So just to give you a better idea on what this looks like, let's take a look at just an example here. So I have a segment PQ, and now I want to perform a glide reflection on this. So the first step in a glide reflection is a translation. It's specifically a translation followed by a reflection. Now this translation is a very specific one. We're going to translate this in a direction that is parallel to our line of reflection. So I'm going to take point Q and I'm going to slide it somewhere in a direction that is parallel to my line of reflection. And the same thing for Q. So I want these two vectors, or I want P and Q to go the same distance. So a couple things here. So we want these to be parallel to my line of reflection, line K. So we're moving in the same direction as that line of reflection. And also P and Q are going to go to the same distance. That just comes from what a translation is. So that takes me to here, and this is my first piece. So I'm going to label this P prime and Q prime. And let me connect these together. And so here's our new segment. This is sort of our middle step. So we translated this in a direction that's parallel to that line of reflection. After we do that, now we're going to flip it over line K. So remember, there are two pieces to a reflection. The first is that the image is going to be the same distance away on the other side of the line. And the second is that the segment that connects together the pre-image and the image is perpendicular. Essentially, our line of reflection is the perpendicular bisector. So starting with P prime, I'm going to go straight down to my line of reflection K, and this is going to form a right angle. So this is a right angle right here. And then I need to move the same distance on the other side. So this other half is going to be the same length, and it's also going to form a right angle. So this is also a right angle. This is the same length on this side. And this is going to end up here, our P double prime. And then I'll do the same thing for point Q. We want to reflect this. So again, K is going to end up being the perpendicular bisector. So we have a perpendicular segment. The two halves are equal to each other. So this side is congruent to this side. And these are forming a right angle. So here is Q double prime. Okay, so in general, that's the way that we do a glide reflection. Again, it's a translation along a vector that is parallel to your line of reflection, followed by a reflection over that line. So now that we have a general idea on what this is, let's do a specific example. So I have triangle ABC with vertices 3, 2, 6, 3, and 7, 1. And I want to perform the glide reflection I have here. So let's start by graphing this triangle. So we have the point 3, 2, and 6, 3. So 1, 2, 3, 4, 5, 6, and then up 3. So here's point B. And the point 7, 1. 1, 2, 3, 4, 5, 6, 7, up 1. We got A, B, and C. So let me connect these together to form our triangle. All right, now taking a look at our translation and reflection, we want to reflect this over the x-axis. So the x-axis here is horizontal. And now to be a glide reflection, we are going to translate parallel to that line. So we want to slide this horizontally as well, which our translation does for us. So taking a look at our translation rule, it is just x minus 11. So we're taking all the x values, we're subtracting 11 from them. So this is just sliding to the left 11 spaces. So let's start with that to get our first step here. So all of these points, we're just going to move these 11 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I can count this out on the graph, or again, we could also do this algebraically. So for example, if I take a look at point B, the x value is 6. I subtract 11 from that. That means that my new x value is going to be at negative 5. So 1, 2, 3, 4, 5, up to 3. So there's B prime. And again, I could do that same thing with point C. The x value is 7. If I subtract 11 from that, 7 minus 11 gives me negative 4. So 1, 2, 3, 4, up 1. So there's C prime. So here's our first step. So our translation, we slid it 11 units to the left. And now we're going to perform the reflection to complete our glide reflection. So we want to flip this over the x-axis. So I just need to move vertically. And then I need to make sure that I'm the same distance away on the other side. So A prime is 2 units away. So I'll go 2 units away on the other side to get A double prime. And I'll repeat that for my other points. B prime is 3 units away. So 3 units away on the other side. And lastly, for point C prime, this is just 1 unit away. So 1 unit away over here, we get C double prime. And just connecting these together to finish this up, we get our final image, which is what we end up with after our glide reflection. Now, just a couple things. The notation here is really important. So I specifically labeled the triangle in green, our first step. I labeled that as A prime, B prime, C prime, all single prime. And then after doing the reflection, our final answer, I labeled that as A double prime, B double prime, C double prime. So the difference between that notation is indicating to whoever reviews this that this is the first step, this is the next step, and they can follow along with the correct order. But that's how you do a glide reflection. It's a translation followed by a reflection.